Hello and welcome to We Dared Chemistry. Today, we're diving into the fascinating topic of the brand new series on Spectral Series, Lecture 1 Introduction of Spectral Series. Let's start. What is a spectral series? A spectral series is a collection of sequentially grouped wavelengths, which describes light or any electromagnetic radiation released by energized atoms. The hydrogen atom is the simplest atomic system found in nature, thus, it produces the simplest of these series. When the beam of light or any radiation is made to enter the device through a slit, each individual component of the light or radiation forms an image of the source. These images can be visualized when resolved under the spectroscope. The images will be in the form of parallel lines arranged next to each other with regular spacing. The lines will be farther apart on the higher wavelength side and gradually closer as they move from the higher to the lower wavelength side. The shortest wavelength with the fewest separated spectral lines is the series limit. Next topic is Rydberg Formula. Atomic hydrogen displays emission spectrum. This spectrum enfolds several spectral series. Once the electrons in the gas are excited, they transition between the energy levels. These spectral lines are the consequence of such electron transitions between energy levels modeled by Niels Bohr. The wavelengths of the spectral series are calculated by the Rydberg Formula. Rydberg Formula relates to the energy difference between the various levels of Bohr's model and the wavelengths of absorbed or emitted photons. It is mathematically expressed as dash, where lambda is the wavelength, r is the Rydberg constant, has the value 1.09737 *10^7 m to the power of -1. Z is the atomic number. NL is the lower energy level. NH is the higher energy level. It should be noted that this equation applies to hydrogen and hydrogen-like elements. Only when NH-NL does the equation return a significant value. The series categorization by the Rydberg formula has played an important role in developing quantum mechanics. They're also important in astronomical spectroscopy, particularly in detecting hydrogen and calculating redshift. If you found this video helpful, please like, share, and subscribe to We Dared Chemistry for more educational content. See you in the next video.